Hey, boys and girls, guess what? You are getting to the end of fractions, and today we're using our fractions to determine probability. So do you remember when we had our little blocks in class and we had so many of one color? I can't remember what color it was. Maybe it was red, and there was 9 red ones and only 1 blue one, and we said, what's the probability of getting the blue, what's the probability of getting the red, and then we mix the different colors. So we can do that. We can find probability. We can use our fractions to help us figure out probability. But before we do that, I want you to look at this page on the computer. Do not go to your book yet, even though we are on lesson 10.12, page 299. I want to do a quick equivalent fraction review. All right. So what do we do to find equivalent fractions? Some of these are easier than others, but let's do a quick review. Oops, here we go. All right. 8 times what equals 24? 8 times what equals 24? 8, 16, 24. 8 times 3 is 24. All right, some of you have been doing like the way of the book, and it's divided by 3 this way, right? And then you multiply it the other way. I'm doing it Mrs. Cornthal's way. Here we go. 8 times what equals 24? 3. What you do to the bottom, you also do to the top. All right, so if 8 times 3 is 24, 2 times 3 is what? 6. Our fraction is 6/24. All right, here we go. 2 times what is 4? Times 2. What you do to the bottom, you also do to the top. 1 times 2 is 2. 1/2 is the same as 2/4. All right, here we go. 7 times what is 21? I always think of Judah when I hear the song. 7, 14, 21. That is times 3. What we do to the bottom, we also do to the top. Excellent. So this is 3 times 3, and we get 9. 3/7 is the same as 9/21. Yes, it sounds funny to say, but that's what it is. Okay, last one for review. 4 times what equals 20? 4, 8, 12, 16, 20. Times 5. 4 times 5 is 20. What we do to the bottom, we also do to the top. So 3 times 5 is 15. 3 times 5 is 15. For those of you who had to think about that really long and hard, review your math facts. Use this time during the break. Well, not break, but use this time at home to get out a deck of cards, play war with your mom or dad or brother or sister, and use it for multiplication review. Who can go faster? I don't know. You tell me. Because you want these quick in your head. All right, here we go. Back to the top. Now we are on page 299. It says probability. Australians enjoy throwing boomerangs. That's this fun wooden thing right there. Stores sell many styles and colors of boomerangs. So far today, one store sold 6 boomerangs. 3 of them, they didn't put it in a number. They actually wrote the word 3. 3 of them had hand-painted patterns. Ooh, I'm going to do this. 1 was red. 2 were green. If the store sold another 6, okay, so this is 3, I'm going to write this here. 3 of them had patterns. That's the pattern one. 1 was red, 2 were green. If the store sold another 6 for a total of 12, predict how many of each style would be sold. What in the world are we doing, Mrs. Cornthal? All they're saying is, boys and girls, 3 out of 6 were painted with the pattern. Okay, 1 out of 6 was red. Okay, I'm going to put P for pattern here. 2 out of 6 were green. So if they sold 6 more, predict how many of each style would be sold. Okay, so what if I told you all you have to do is look at the numerator? It's kind of easy. We'll look at these, but the book's going to break it down for us, and I'll show you. Okay, so here's how it works. Let's stick with me, go step by step. If 3 out of the 6 have a pattern, then 6 out of 12 will have a pattern. Here's why. If I were to just take this and I would double it, right? Because 6 doubled is 12. I would double it and that would be 6. I'd double the top number, that would be 2. I'd double this number, that would be 4. But let's look at it in equivalent fractions. Are you ready? So if we had 3 out of 6 that were the pattern, stick with me, and I know that there's going to be 12 instead, how did I get to 12? 6 times what equals 12? 6 times 2 equals 12. So if they sold 12 instead of 6, they doubled their sales. Here we go. What we do to the bottom, we also do to the top. So this would be times 2. 3 times 2 is 6. So if they sold 3 out of 6 with the pattern, they'll probably sell 6 out of 12 with the pattern. Okay, now is this a guarantee? No, it's probability. Might someone come in and really love red and buy all the reds? Yes. But in general, this is how probability works. So if 1 out of 6 is red, I'll even use red. If 1 out of 6 is red, 1 out of 6 is red, 2 out of 12 would be red. Why? Because they just doubled it. Let's show you. Over here, move on over. So if we're trying to figure out, if we know 1/6 is red, and we're trying to figure out, well, how many will there be if there's 12 instead of 6? How do we get to 6 from 12? 6 times 2 is what? 12. What you do to the bottom, you also do to the top. So times 2, 1 times 2 is 2. So we can expect, if we double it, that we would get 2 out of the 12 sold will be red. Okay, last one. Don't fast forward through this part. I want to make sure you're getting it. Okay, green. If 2 out of 6 are green, 2 out of 6 are green, we can expect 4 out of 12 will be green. Why? Let's look at it. 6 to 12, guess what? Same pattern. They doubled their sales. 6 times 2 is what? 12. What we do to the bottom, we also do to the top. Times 2. 2 times 2 is 4. So we can expect if they sold 12 instead of 4, if they sold 12 instead of 6, they will get 4 out of 12 will be green. And that's why. Okay, keep on moving. Let's look at our averages here. So the boomerang store sold a total of 18 boomerangs. How many of each style did they probably sell? So let's look at it. All we're trying to do, so if they sell 18, how many do you think will be the pattern kind? It was a pretty pattern. I like that. I can see why they sold more of those. Okay. 6 times what is 18? 6, 12, 18. 6 times 3 is 18. What we do to the bottom, we also do to the top. Times 3. 3 times 3 is 9. Excellent. Okay, again, 6 times what is 18? 6 times 3 is 18. What we do to the bottom, we also do to the top. 1 times 3 is 3. Good job. All right, greens. If they sell 18, 6 times 3 is 18. What you do to the bottom, you also do to the top. So if they sold 2, when they sold 6, when they sell 18, 2 times 3 is 6. They'll probably sell 6 green ones. Do you see that? All right, here we go. This one's fun. Okay, answer the question about the tennis balls. So I want you to stop and think about this. Do not just copy down the answers, boys and girls. Stop, think, stretch your brain. Okay, answer the question about the tennis balls. Well, let's examine the tennis balls before we even look at the questions. Are you ready? What do we notice about the tennis balls? How many purple ones, bluish purple, are there? 1, 2, 3. Okay, how many yellow ones are there? 1. How many pink? 1. How many orange? 1, 2, 3. And how many total? What would be our denominator out of these balls? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total. All right, do you see that? So now that we have that, we know there are 8 total, and whatever we discovered out of those colors will be the fraction. So what does it say? Are you more likely to pick a yellow or a purple? Well, yellow, how many did we have? Yellow was only what? Yellow was only 1 out of 8. And purple was 1, 2, 3 out of 8. So what do you think? Your chance of picking yellow or purple, you're going to pick yellow. 3 out of 8 is a much higher chance. Purple. You're more likely to pick a purple ball. Okay, which 2 colors are you equally likely to pick? Which 2 colors are you equally likely to pick? Ooh, there's actually 2 answers for this. Because the orange has 3 and the purple has 3, but the yellow only has 1 and the pink only has 1. So you have 2 choices. Because it's either orange and purple. Do you see how there's 3 out of 8 for orange and purple? 1, 2, 3, 1, 2, 3. Or yellow and pink. Because those are both what? 1/8. 1 out of 8 is a chance. And the orange and purple are what? 3 out of 8. Do you see that? So it's either this set or this set. Okay, how many orange balls, number 6, how many orange balls are you likely to get in 8 picks? So if I were to pick 8 times, how many orange balls? So if I picked 1, 2, 3, 4, 5, 6, 7, 8, well, what do we know? There's 8 total. So how many orange balls would I pick out of there? Well, if I picked all of these out once, I would get 1, 2, 3. If I picked them all, I would pick all orange. I'd pick them all out. And how many orange were in that whole set? 3. I'd pick 3 orange. Ooh, but what if we had 16 picks? Okay, well, 3 out of 8 are orange. What if I picked 16 instead of 8? I put them back in and I picked them all again. How many orange would I pick? 8 times what is 16? Times 2. What I do to the bottom, I also do to the top. 3 times 2 is what? 6. So if I picked 16 times, how many orange balls am I likely to get? 6. Excellent. Do you see that? Awesome. Okay, so it says complete the following probabilities. What would you predict for 10 picks? It says 2 out of 5. Okay, so if I have, I'm going to move this out of the way a little bit. If I have 2 out of 5, what would I predict for 10 picks? 5 times 2 is what? 5 times what is 10? 5 times 2 is 10. What I do to the bottom, I also do to the top. 2 times 2 is 4. My answer is what? 4. So if I pick 10 times, I would expect, if the probability is 2 out of 5 to get whatever it is, and I pick 10 times, my chance of getting that number is 4. I'm just going to leave the work here and circle my answer. Okay, let's do another one. If it's 2 out of 8, okay, let's say there's 2 chocolate candies out of 8 total candies, and the rest are Skittles or something. Or 2 yellow Skittles out of the bag of Skittles of 8. There's only 2. Well, if I pick 24 times, how many yellow Skittles do you think I would get? So it was 2 out of 8. But if I pick 24, how many yellow Skittles do you think I would get? Well, 8 times what is 24? 8, 16, 24. 8 times 3 is 24. What I do to the bottom, I also do to the top. Times 3. 2 times 3 is 6. So if I had a bag of 8 Skittles and 2 of them were yellow, I can predict that if I had 24 Skittles, 6 of them would be yellow. Do you see that? Okay, 4 out of 9. Now I'm at M&Ms. 4 out of 9 M&Ms actually had peanuts in them in this mixed bowl. Now, if I picked 18 out of the bowl instead of 9, how many of those do you think would be peanut? Well, let's figure it out. 9 times what is 18? Times 2. 9 times 2 is 18. 4, what we do to the bottom, we also do to the top. Times 2. 4 times 2 is what? 8. So if I picked 18 M&Ms out of the bowl, I would guess the probability would be 8 out of those would have a little peanut in there. Okay, let's look at the next one. 1 out of 4. So I have 1 out of 4. What can we do this time? 1 out of 4 race cars in the basket are blue. Okay, so if I picked 8 cars out, if I picked 12 cars out, how many do you think of those will be blue? Well, let's check. 4 times what is 12? 4, 8, 12 times 3. 4 times 3 is 12. What I do to the bottom, I also do to the top. So I multiply by 3. 1 times 3 is 3. So if I was picking 12 race cars out of the basket, I would guess that 3 out of 12 of those would be blue. Okay, 5 out of 6. 5 out of 6. Let's see, what can we do this time? There's 5 out of 6 cookies in the basket were chocolate chip. Okay, they're mostly chocolate chip. The other ones were oatmeal. But 5 out of 6 were chocolate chip. What if I picked out 18, I passed out 18 to the students? How many of them would probably be chocolate chip? Let's see. I'm going to highlight the answers for this. Missed it. Four, 6, 8, 3. Okay, my answer for the next one. 6 times what is 18? 6, 12, 18 times 3. What I do to the bottom, I also do to the top. Times 3. 5 times 3 is what? 15. So if I was passing out cookies, I would bet 15 out of those 18 would be chocolate chip. Okay, last one. Are you getting the swing of it? Try it on your own. I'm going to give you a minute. It says 5. Oops. It says 5 out of 8. So what's your fraction? 5 is the part. The numerator's the part. The denominator's the whole. And fractions are parts of the whole. So the numerator's the part. So what's the part out of 8? 5. That goes in the numerator. Out of 8, that's the whole, out of the total. What would you predict for 16? So if I have 5 out of 8, let's see, 5 out of 8 gummy bears in the bag were red. 5 out of 8 gummy bears in the bag were red. But I'm going to let you pick 16 gummy bears. How many do you think will be red? What's the probability? Well, let's set it up. If I pick 16, that goes in, that's my new denominator. What's my new numerator? Let's see. I'll find out. 8 times what is 16? 8 times 2 is 16. What I do to the bottom, I also do to the top. 5 times 2 is 10. So that's how many gummy bears, what did I say, would be red. So if I was picking 16 gummy bears out of the bag, I would guess that 10 of those would be red because that's the probability. All right, moving on down. These cute pictures. 3 Australian animal stickers are in a bag. 3 Australian animal stickers are in a bag. You pick one without looking. Answer the question. Sorry, not 3. These. That means these guys. So how many animal stickers do we have total? What would be the denominator? 1, 2, 3, 4, 5. There's only 5 stickers there. That's our denominator. That's the whole. And somebody tell me, think about it, what fraction of those animal stickers are kangaroos? 1/5. Do you see there's 1 there? What fraction would be the birds? 1, 2, 3. What fraction would be a koala bear? 1. Okay, name an impossible outcome. What in the world are they talking about, Mrs. Cornthal? What would be an impossible outcome? That means it could not happen. So if I said a koala bear sticker, would that be impossible? No, because I have 1 out of 5 chance of getting a koala bear. What would be impossible? The funny thing about this one, boys and girls, it just means something that's not in the bag. Okay, these ones are in the bag. Everything that you see here is in the bag. So an impossible outcome would be pigs or ladybugs, a ladybug sticker, or a butterfly sticker, or a horse sticker. Okay, so any impossible outcome is just something not in the bag at all. That's the only way it's impossible. Because if it is in there, there's a chance, right? You can get it. Even if the chance is low, it's still possible. Name a certain outcome. What? None of these are certain, Mrs. Cornthal. Because what if I reach in, one time I can get a kangaroo, but the next time I might get a koala bear? What could be a certain outcome? I know what I could say. An animal sticker. Are they all animals? Yes. So no matter what I do, certain, that means 100%. Like no matter what, you will get it. So no matter what I do, if I reach in the bag and I pull out a sticker, it will be an animal sticker because the bird, the koala, and the kangaroo are all animal stickers. So certain outcome is that I will get an animal sticker. Name all the possible outcomes. So before it was impossible, do you see that prefix right there? Impossible means not possible. Not possible. Now all the possible outcomes, what would that be? Well, I could have a kangaroo. And that would be what? I'd have 1/5 of a chance of getting that. That's possible. I could have, this bird is called a cockatoo. It's a fun name. If you want to just write bird, I would take that too. Cockatoo. I'll put bird in parentheses. And the probability for that one is 3/5. And my last possibility is a koala. And we knew that that was 1/5. These are all our possible outcomes. And these are all, fifths. And these are all stickers. So the only possible are the kangaroo, the cockatoo, and the koala. So possible has to be something in the bag. Certain is what everything is. Like no matter what, when you pull it out, that's going to be it. Impossible means it's not in the bag at all. Now on this line, if you wanted to write something silly like a car sticker or something random, please do that. So write the probability of each outcome. I kind of answered that already for you, but let's look at it again. So the koala, we know that all of these are out of how many stickers? 1, 2, 3, 4, 5. Everything is going to be out of 5. No matter what, that's our denominator because that's how many stickers there are. All we do to find the numerator is what? See how many are in the bag. How many koalas are in the bag? How many koala stickers? 1. How many kangaroo stickers? 1. How many cockatoo stickers? There's 1, 2, 3 in the bag. 3 out of 5. Do you see that? Awesome. That means you have really done well with fractions. Super awesome. Let's see. What is the probability? What is the probability? Let me think. I'm trying to remember how many girls are in our class. I think there's 6 of you. What's the probability then if I were to just randomly, you guys were all in a room and I closed my eyes and I just reached out and tagged one of you in the classroom? What's the probability that if everyone was there, no one was out sick, what's the probability that I would tag a girl? The probability would be 6 out of 21 or 6 21st because there's 21 kids in the class. What would be the probability of me tagging a grandpa in our classroom? On a regular day, the probability would be 0. That would be an impossible outcome. What would be a certain outcome? Well, if I closed my eyes in our classroom on a regular day and tagged somebody, a certain outcome, I could say, would be a 3rd grade student, right? If I reached out and tagged somebody, for certain, 100% certain outcome is I would tag a 3rd grade student. What are all the possible outcomes? Okay. Possible outcome is I could tag a 3rd grade boy. Possible outcome is I could tag a 3rd grade girl. Okay. So possible means it can happen. Certain means for sure it's going to happen. And impossible means there's no way it could happen. All right, quick review. I love you. Continue to love God and love your neighbor. I love how you're still growing and learning. Give yourself a pat on the back today. Go give someone in your family a hug or a high five and tell them they're awesome. And pray about how you can love God and love your neighbor today. Remember, I love you. Have a great day.